Good afternoon, all. Well, welcome to the class. And as I told last time, that today we are going to start with a very important topic. Once you have done the basic programming based on arrays, etc., and understood the basic concepts behind the arrays, let me now start with talking of the new concepts, which are based on pointers. So today we are going to start with the pointers. I'm sure all of you have studied last semester pointers, but some of you might not have a good clarity. And once we learn the pointers, ultimately we are going towards the one of the most important data structures which you should learn is linked lists. So linked list will require a thorough understanding of pointers, and today we will start about talking of pointers. Basic concepts we will revisit, and some new concepts which will help you in remembering the pointers well, I'll discuss. So, pointers appear to be a difficult topic, but if you listen carefully today's lecture and there are effectively 4 or 5 main rules which you remember, then everything will be solved easily. So, first of all, what is a pointer? We all probably know, but I'll say remember that it is nothing but it's an address of a memory location. Irrespective of any data type, it will be always address of a memory location. Why memory location? Because most of the time my address will be used reference to variables, but remember all variables are stored at some memory location, and irrespective of data type, the pointer will be always pointing to the starting address or starting location of that memory location, whatever number of bytes. Yes, let's start one by one. So address of a memory location, where we have not till now used address, we have been dealing with variables, values, etc. How to declare? Let's say I say int, if I have declared A as one variable, B as another variable, and if I write int star PA, let's say I'm making PA as a pointer to A, kind of a variable name, star PB. So what effectively I have declared, this declaration line means they are declared as pointers. So how to read? I say PA, always read with the variable name. What is PA? PA is, star means a pointer. So effectively it means PA is pointer to an integer. Similarly, PB also. In general, I say PA is address of a memory location. At present, it is a pointer or address of some memory location. Currently, PA is not pointing anywhere. To understand it in a better way, always remember that when you write any variable declaration, it is internally equivalent to assigning it some memory. So this becomes A, some memory location. This becomes another memory variable, B, which is getting this. And because A has been given as a 10, this becomes initial value. B has been given as a 20. When I write int star PA, that also means a variable created. A variable created effectively means some memory box created whose name is a PA, and another memory box created whose name is a PB. And currently they have some random garbage address. At present, they don't have a correct address. So they can point to some location, but where they are pointing, at present, no idea. So currently they are pointing to some garbage or memory location. Then, remembering this, so effectively, I always use the concept of later saying that we will write PA to be given some address, and we write something like this. I'm sure you have done in the past, so I'm not telling why and how it is being done, but I'll explain that part also. So PA equal to ampersand A effectively means PA is now made to point to A. And similarly, PB equal to M% of a B. That means now it points to B. Why? M% of A means address of A, address of variable A, address of effectively A's memory location. Because I said every variable means some memory location stored. Address means what? So each memory location has some address. For the time being, let's assume this is 1000 hexadecimal address because address are normally represented into hexa. And let's assume B's address is 1200 hexadecimal. It could be any address, but I'm just assuming this. Effectively, M% of A means 1000H. And effectively, this statement is equal to 1000H. So effectively, internally, what has happened is this 1000H is stored here. And similarly for the B also. So when we use variables and pointers, internally, of course, there is no this kind of arrow and links. So at the hardware level or at the physical memory level, you say when A and B, they are some memory locations, they have 10 and 20 value, and PA will indirectly mean in PA, it is stored as 1000H, and in PB, it stores 1200H. Because PA equal to this address effectively means PA equal to 1000H. And similarly, PB equal to M% of B is equivalent to say PB equal to 1200H. So ultimately it's a variable. This is assigned this particular data, which at present is an address. Indirectly or logically, it means it is pointing to this because we know that this is a variable of pointer data type. So indirectly, we understand that 1000H is nothing but it's an address of this particular memory location. Hence, this is what is happening internally. Now, once you remember this basic concept, there will be always two things. In the program, maybe I will write somewhere x equal to star PA. Or maybe I will write y equal to PB. Or it could be star PA equal to something or PB equal to something else. But two different syntaxes. One I will use with a star, one I will use without a star. So what does this mean? Remember, star PA, it means nothing but value at address point, value at memory location or address, what you say memory location or at address pointed by PA. On the other hand, only PA will mean address pointed by PA. So remember, star means value and only without star means this. But this means during their use. Why I am saying? At the time of declaration or definition of a variable, star meant different. At that point, if I write int star PA, here it means PA is declared or defined as pointer to int or char or whatever. So at this point, star used will mean that asterisk during declaration list used only mean that it is declared as a pointer. But during use, star means value and without star means address. Just so I will say this, remember rule 1, just remember rule 2 and rule 3. 1 and 3 are effectively same. So I can say, you can say, let's say this is R1 and this is R2. So it is repeated. But just remember that during usage, it will mean this. So if you remember this, I will say R1 itself again reproduced in a better form. So I will say R1 means address and this means star means value. Remembering this, X equal to star PA means what? Star PA means value at address of PA, pointed by PA. Where PA is pointing, I know, but if it is a value, it means X must have been of int data type because star PA will be an integer. So effectively, it means X must have been declared something like this. But star PA, referring to the same example, PA means 1000, star PA means value at address 1000. This is address 1000. This address is 1200. So I'll say value at address 1000. That will effectively mean star at 1000H. That is effectively meaning that X will become equal to 10. And that also means there is another variable created X, which will have some address, X gets 10. Then I say I wrote Y equal to PB. PB means rule R1. PB is address pointed by PB. What is that address? I can see PB means 1200. So effectively, this statement means Y also must accept an address. That means Y also must be pointer type. So that indirectly means Y should have been declared something like this. Only then Y can be given an address. Otherwise, it's supposed to get value. And for this effectively means Y equal to 1200H. This indirectly means that Y is another variable and which also now starts pointing to the same place where B is pointing to. Now, if you do A plus plus, remember what will happen. A is here. This becomes 11. Indirectly meaning PA also points to value 11. Similarly, if you write star Y plus plus, remember star Y means value at address 1200H. At this is effectively 1200. Value at 1200 is this 20. Increment to this makes it 21. But this also means B's value also changed. It also means star PB has also changed because PB was also pointing there. So simultaneously, values change at multiple places. I hope this is clear. It will be much more useful now if we go further and understand bits. Then, having said that, let's see and some simple example. Say I have written some code with proper data types declared for whatever variables I am using. And you can easily make out that A, B, C I'm using, that will mean they must be of integer type. Then I say I have some statements like this. Then I have, let's say, star PA equal to star PB plus star PC. Say I have written something like this. Then I have written PC equal to, let's say, PB, PB equal to PA, and then let's say I have done some more changes. Say I have done A plus plus, B minus minus, C plus plus. And then let's say I write star PA plus plus. Then let's say I write PA equal to PC. And then I write star PB minus minus star PC plus plus. And I'm asking you now, after this, tell me what will be the value of A, what will be the value of B, what will be the value of a C, what will be the value of a star PA, what will be the value of a star PB, what will be the value of star PC. Having understood the previous discussions, I am sure you must be able to calculate this. Use memory boxes. It will be always a good way to explain and find correct answer. For pointers, the concept of memory boxes and pointers, addresses, etc. will be very useful. Solve this, and those who want to try, they should pause the video now and get the answers, because after that I will be explaining how it works and I'll also tell the final answer. So those who want to try, they should pause. I'm giving few seconds pause, and then I will be resuming with my discussions, and you can pause and then replay. So I hope that you are trying and you have done now. And those who have done, once they replay, now they can see what will happen. Let's go one by one. This side, I'm writing equivalently what happens after every line. A is declared as a variable as this. B is declared as a variable like this. C is declared as a variable and gets data this. With some addresses, for the time being, I'm not writing address, but yes, that will happen. So I just assume some addresses there. You wrote PA, so PA is already a box. When you declare a variable, box gets created. When you start assigning it some data, it gets data. So at present, PA is empty or not empty, I'll say some garbage. As soon as you wrote PA equal to %A, it started pointing here. To be precise, it points to the first location or first byte. If there are multiple, so you show it anywhere, it effectively means it is pointing here. Similarly, PB was already existing as a box once it was variable created or declared. And then now PB equal to %B means this work. PC equal to %C simply means again this. Then what next? It says star PA equal to star PB plus star PC. For this, remember, I will start evaluating from after assignment, and the calculation will be assigned to star PA, star PB. So now just see, star is also an operator, but it is now a unary operator. Star is also used for multiplication, but here star being used with the pointer concept will mean unary operator. And star PB effectively means value pointed by address PB. So value at address PB. PB is this and this is 20. So effectively star PB means plus. Star PB means 20. Then comes plus, then comes star. Effectively here, another concept of your operators precedence comes into picture, and you already know that the precedence of a star is more Hence, this plus will not be evaluated. This side will be evaluated first because the star is more. And precedence table you have already seen. So you know star is more precedent. Here also the same, but because star is more precedent, so automatically plus will wait, star PC will be evaluated, and star PC I know what is there. Along with precedence, the associativity also comes into picture. Associativity will define for the same operator what is the order of execution, left to right or right to left. For mostly it is left to right, but for few operators it could be right to left also. Although in this case it is not being material because star PB was separately done. Now after plus star has come, so it's a new operator. So star PC will be now being discussed, and star PC means where PC is pointing. So PC is pointing to 30. Star PC means as per rule R1, it means 30, value at address. So value at address. So it becomes a star PA equal to, equivalent statement becomes a star PA equal to 20 plus 30, that means 50. 50 to be assigned to star PA. Star PA means value at address PA. Value at address PA. Again, same R1 rule. That means here it was 10, it becomes 50. PA is pointing here, so it becomes 50. Indirectly, you can say A has also changed. Then you write PC equal to PB. Again, what is PB? As per rule R, I'll say this was rule R2, and this was rule R1 tells PB is an address. So PB is an address. This address means this address where it is pointing to. PC to be a PC means what? Again, a rule R1 says PC is an address. So PC is to be given a new address. What is new address? PB. If PB was, let's say, 1200, effectively this will mean PC also gets 1200. Indirectly meaning PC is pointing here. So my PC means this. Then I have PB equal to PA. Again, as per rule R1, PA is an address and PB is assigned a new address PA. So PB is not pointing now here anymore. PB equal to PA means where PA is pointing, this also points. Next, A plus plus. A plus plus means this increment becomes 51. B is increment, B is decrement, B minus minus. C plus plus, 31. Done. This statement over. Now it says star PA plus plus. These brackets automatically ensuring that precedence will be for bracket first. So star PA to be first thought. Star PA means rule R2. Star PA means value at address pointed by PA. PA is pointing here. PA is pointing here. So this becomes what? PA is pointing to 51. And now I say increment this. So it becomes 52. It becomes 52. And once it becomes 52, this statement is over. Then comes PA equal to PC. PA equal to PC, again rule R1. PC is the new address to be assigned to variable PA. PA is currently pointing to A. It should have the address of a PC. PC is effectively, let's say 1400. Say this is 1400H. This is, let's say 1200. So this was 1200. Let's say this is 1000. So this was earlier 1000. So PC earlier was 1400 and now PC is also pointing here. So PC earlier became from 1400 to 1200. Similarly, PB was made from 1200 to point to this side. So PB also changed. So currently PB is 1000, PC is 1200. And now I said PA equal to PC. So PA equal to PC means effectively PA equal to 1200. 1200 means this location because PC is here. So indirectly meaning now that this is my A, which has a 52, which has B as 19, which has a C as 31. And now I say PA equal to PC. So PC was here. PC is pointing to B. Now PA also starts pointing to B because of this statement. And at present, PB is pointing to, I can see, to this value. And now this statement over. So I said star PB minus minus. Star PB, value at address of PB. PB is here, minus minus to this. So this 52 becomes 51. I said star PC plus plus. Again, rule R2. Star PC means value at address of PC. This is a 19. Hence, this becomes a plus plus. So this becomes 20. So now I can easily see A equal to what? A is a 51. I can see. B equal to what? 20. I can see. C equal to what? 31. I can see. What is star PA? Address PA, where at this address value is star PA. Star PA means rule R2. So rule R2 says value at address PA. PA is pointing here. Value is 20. Star PB. Rule R2. Value at address PB. PB is pointing here. This is 51. Star PC. What is PC? PC is pointing here. Value at this address. This means 20. So currently the output or the values will be these values. Having said that, I'm sure now you are clear and you can solve this easily and similar such problems. So with these R1 and R2 rules, if you remember, you will always be referring to the correct output. Knowing this, let's reconnect some of these concepts to what we have been doing earlier, and we have been using this. I say this, we said address or pointer. You have earlier also used this concept at many different instances or indirectly used this. And one of the most common use which you have done in the past is in the scanner. You have been writing percentage, whatever percentage, DEC, etc. you write, but later you have been writing M% of something, M% of X. M% meant what? And it was compulsory in scanf to write. So it meant always address. We have just seen that M% means address. So address of X. That means effectively we have already used this concept. And why M% or address was needed? So there is internally for scanfs working, the rule is that scanf must be told address of the location where the new variable or new red value is to be stored. So we always, scanf needs address of the memory location, and hence we are forced to always supply the address using M%. Printf we don't use because in printf the value is directly printed, address is not to be supplied for that. But indirectly meaning that we also remember that it always needs an address, but there have been some places where we didn't use M%. For example, you have declared char str30 and then you said scanf %s and then you used str. No M%. But We say rule is scanf always needs address. That indirectly gives me another idea that str is itself an address. And that's why scanf did not use ampersand here. If it is an address, what is that? So we will understand when we use arrays versus pointers will also become an important concept. So we will talk of that. And I can easily see that the string, etc., that was actually as an address if I declared it as an array. So what is that? How it is that? We will understand that. But we can correlate all these things now. Then, can we print the address itself? That is another question. Like I said, we will print star PA. And I said, yes, in the previous case, star PA will be printed as 20. Star PB will be printed as 51. And similarly, star PC, say 20. I want to verify whether my PA, PB, PC are pointing to the real locations which I have just thought. Means, what if I try to print PA? Yes, I can print the address. The only thing is, normally for printing the address, we don't use %D. We normally use %X or sometimes %P. And if I write PA, %X is used for address or pointers printing. And address printing, that also in hexadecimal. So X is normally used for hexadecimal number system, and effectively %X can be used. %P also can be used for pointer printing or similar address printing. So anyone can be used, and you can use this for this. So effectively, this will give you address like in the previous case, PA was pointing to B, which was address 1200. So I can expect some 1200 H to be printed like this. I can verify this by printing printf %X address of B. M% of a B also means address. So this will also get printed as a 1200H. I can match that in the previous case, they were pointing to this. So you can print the pointers also. You can print the integers also using ampersand also. Ideally speaking, even PA is a memory variable. So ampersand of a PA will mean the address at which a PA variable is stored. But of course, we don't need at present, so we will not go into that detail or complexity more. Having said that, I say now, this concept I can always use to verify whatever I have learned. Then coming further, and I'll say, based on this, I just said there is a concept of addresses versus arrays, pointers versus arrays. So effectively, whenever you declare either character array or integer array, there is always a link between this versus pointers. If I declare char str30, both effectively mean some pointers come into picture. So internally, what happens? Whenever you say ARR is actually, or str, we just said it's an address. So we'll say, yes, ARR word is, I'm leaving some space here, is an address of the starting memory location, because there will be multiple locations now. Starting memory location of 20 integer storage. I said 20, so I got 20 integer storage or box. Obviously, it is a contiguous memory. And in last class, we have discussed the same concept already. So starting address or starting memory location. in row major ordering or those discussions also, I said that you have a base address. So now you can easily see effectively this becomes your base address. So this is how computer will internally know the base address. The ARR variable, when you created it like this, so effectively my ARR is nothing but it's a pointer to the starting location. 20 integer box could mean 40 bytes or 80 bytes. It means starting address. Effectively meaning, if I say what is the address of a starting element, array 0 is a value. M% of that means address of that value. So this is nothing but this is equal to ARR. So whenever I refer to word ARR, it is address of 0th value or address of the starting location. So if this location is, let's say 2000H, there will be maybe 40 bytes or 80 bytes, but ARR always has that address. So some of you might be thinking, what should be I filling here? So probably now you will say it is a base address. Yes, you could be almost okay that I am supposed to write here base, but indirectly, I have already written that base word through starting location. Starting automatically meant the base address. Hence, I have specified that. So this is important now. I write here, it's a constant address. Constant. So what I mean is ARR is a pointer, but it is a constant pointer. So I will say address or I will say pointer, whatever you say. Pointer will be more technical word to understand. Constant, why I mean that array will not be allowed to point to any other location. So if I had declared PA, it was a pointer. But I was allowed to write PA equal to PB, etc. But if I declare int A, this was ARR, let me correct that. If I write int ARR 20, ARR is a pointer. Perfect. Yes, it is a pointer, but it doesn't mean that I can write ARR equal to PB. No, because ARR is constant pointer. Constant pointer means it is not allowed to change its value or it is not supposed to point anywhere else. And that is obvious also because I have got here 40 bytes to be accessed whose variable is guaranteedly named as ARR. So ARR 0 should always remain here and so and so. So ARR is a pointer but a constant pointer. So remember your array name is always nothing but it's a constant pointer. And rest everything is the same. So my str is also, when I wrote str30 char, this also means str is a constant pointer. Of course, pointer for storing character values, but at pointer address, only address is stored. So the pointed address or pointed memory locations will store characters, etc. But remember, irrespective of any data type, everything is an address. At that address, the data type will come into picture, but everything is just an address. So it means whether you have a char pointer or you have an int pointer, all pointers are nothing but address. Having said that, I think I'll stop here and I will give you time to revise all these concepts. And next class, we are going to do some discussions of this. And we are going to study some more about pointers. And after that, linked list will start. And in the meantime, today you must read some C book, read and revise these concepts. And along with that, I have some time, so I'll go for some more discussions. So first I will say, for your homework or for your practice, what you should do is go to book of any C book, and there are some unsolved problems given for pointer-based results, pointer-based plus minus done, and values to be printed. Values or output to be told. So just revise those and practice that, and you will be able to understand and get more clarity. And read from the book also the pointer related discussions, at least up to the topic which we have discussed now. Along with this, now I say again, do you remember you have used already pointers somewhere else also? One is you have used with the scanf, that where you have used address ampersand, but you have used pointers for somewhere else also. Where? I'm sure all of you have used it in swapping two values. All of you have used the call by value and call by reference. For that purposes you have used. Maybe some of those concepts are correlated and now you will understand it in a better manner. Just recall, how did you swap two values? You wrote void swap int star x int star y, and then here you had int temp, and then you wrote temp equal to star x equal to star y equal to temp. And you say this worked because it was a call by reference. From the main, how did you call? In the main, you had, let's say, int a equal to 10, and maybe int b equal to 20. And then you called swap ampersand of a, ampersand of b, and then if you see a equal to now and b equal to now, so you get a 20, b 10. You have done this. Indirectly, you have used here pointers. This is a declaration. So I say x is a pointer to integer. Y is a pointer to integer. And you say it is a call by reference. And it was able to replace. On the other hand, if you use the concept of a call by value, it didn't allow. What happened? Let's recall and see that. By default, parameters are passed as a call by value. That will mean no pointers used. That will mean effectively my swap function will be written something like this. Say int x, int y, and here also you will have, say, temp equal to x equal to y, and y equal to temp. And similarly, of course, int temp declared here also. And then in main, you have all that same int, all this. And then you have here a function swap ab, where I say I have declared int a equal to 10, comma b equal to 20, swap ab. And then if you see the value of a and see the value of b, you will get no change, and we will get 10 and 20. Just remember, if I have to put a semicolon here, int word was written. Here I have written in the same line with a comma, so I can write within the same line. Just to show you that why there is int written. Why this didn't work? Why it really was not able to change? You say that it is going to be called by value. Sorry. When I said that, yes, now I'm going to have this value like this, why it didn't work? Why the values were not swapped? So there is a specific reason which now through pointers you will understand. I say call by value means that in functions, parameter passing takes place. Obviously, parameter passing is there. So whatever parameters are declared inside the function's header, they are called as the formal parameters. So my x and y are actually formal parameters. And during a call, whatever actual variables are sent, they are called as actual parameters. For example, in this case, I had A and B as actual parameters. So call by value means whenever the execution takes place, value of actual parameter or actual parameters, all parameters is copied or assigned. Value is copied. Copied to the corresponding formal parameters. What does that mean? Value, and that's why it is called as a call by value. But remember, it is actually a simpler concept. Value is copied. What does that mean? Let's understand now. Whenever you declare, even if a formal parameter, internally a memory box is created. Variable means always a memory box. Anytime you refer to X, it refers to this. Temp also meant a memory box. Currently, all these have garbage. As soon as the call took place, so int a equal to 10 means a is another box. Of course, main has a separate box and other function has a separate box. So even if two sides we have same variable name, they will be separately existing. B is another variable. Here you got 10, here you got 20. Swap AB meant go to this function. When the function execution is started, first of all, parameter passing will happen, parameter transfer. Rule is value of actual parameter is assigned or copied. So A's value 10 is assigned or copied into X. B's value is copied into Y. Now, temp is initially garbage. Temp equal to X meant temp becomes temp. X equal to Y. X equal to Y. Y is 20. X becomes 20. Y equal to temp. Y is 20. Temp is 10. Y becomes 10. Perfect. Values have changed. You can verify that by printing here your print of X and Y. You can verify that they will print 20 and 10. But now the issue starts. As soon as function is over, the parameters or all local variables, all these get destroyed. All local variables destroyed. Once the function execution is over, your all local variables and formal parameter also mean your equivalent to local variables. Hence, they don't exist anymore. Now, you can easily see A is still 10, B is still 20. So you get still 10 and 20. But once you say call by reference, things change. In this case, formal parameter refers to the corresponding actual parameter. During a call, it will refer to corresponding actual parameter. Indirectly meaning that address is passed, not the value. So that's why it is there. What does that mean? A was created as a new variable 10. Similarly, because of this, B was created as another variable 20 with value 20. Here I have the above of this as my function. This also meant X was created as a memory box. Y was created as another box. Temp was created as another. But parameter passing method changed. The address is passed, not value. Address is passed. What does that mean? If this is there, or I said it starts referring to. So actually, X is now referring to A. Y is now referring to B because address was passed. So 10 and 20 are not copied. You can compare with the other side. This address or reference is created. Through that, what happens? Temp equal to star X. Star X means rule 2. Rule 2 means value at address pointed by X. X is pointing to this address. Value at this address is 10. So temp becomes 10. Then you say star X equal to star Y. Again, rule R2. Star Y means value at address pointed by Y. Y is also pointing here 20. So star X to become 20. Star X. Star X means value at address pointed by X. This location gets 20. You can see now the change happened here. After that, you said star Y equal to temp. Temp is already 10. I have stored. Star Y means rule R2. Value at address pointed by Y. Value at address means this value. At this point, the value to change. Star Y to become 10. This changes to 10. Function over. Function over means all variables destroyed. This link no more existing and over. But indirectly, you can see A has changed, B has changed, and changed output is visible here. So that is what call by value and call by reference mean. Going further, let me just give you one more insight into the same discussions that ideally speaking, if you see carefully, parameter passing has not changed much. Effectively, exactly the same process has happened. When I said void swap int star X star Y, what was passed? You said that now it is a call by reference. I say, well, you let it call by reference, but nothing has changed. X was a memory box, which is supposed to store an address. Y was a memory box, which is supposed to have an address. Here, A is a memory box, which has a 10. Let's say this address is 1000H. B is another memory box, which address is 1200H. And this value is 20. I say, effectively nothing happened. When I said swap M% of A and M% of B, I supplied M% A as a parameter. M% A means what? It means 1000H actually. So 1000H was actually copied here. M% B meant what? 1200H. So 1200H was actually copied here. That indirectly meant that it is pointing to this location, and because it is a pointer, and hence everything happened like that. But ideally speaking, nothing big, but this is precisely what it means. So call by value, we normally say that a value was copied or assigned. And when we say call by reference, we say address was assigned. Address was sent. But actually address set means effectively the similar process. So, or I say reference to the actual variables happened. So this is what really is happening. So call by reference means reference or address was sent, and in case of a call by value, value was sent. But actually, if you see, we have passed itself the address, obviously address was supposed to go. So this change really helped me implementing everything. So remember, in case of all functions, by default, call by value happens for a normal integer, etc. Call by value obviously happening because all values are passed by default. But in case of arrays, if you see, while sorting, we passed an unsorted array, and without doing anything, array got sorted. Actually, this was passed as a function or passed as a parameter, passed as a pointer automatically by default because array is actually a pointer. Hence, the pointer got passed and hence the changes in array were visible. Changes in array worked, went back also. But for a normal variable, your main calls something, your function is here, you send the data to the corresponding variables. It's a one-way transfer, sent like this. Reverse, never sent. The same value never sent back. So one-way transfer, one-way copying. After function over, this data destroyed and nothing happened. With arrays, it was different. So having understood that, now I will say, I'll give you some homework extra for this also, that using parameters and no global variables, you should implement stack and queues. No global variables anymore. Implement push pop for the stacks. And implement insert queue and delete queue for queues. And because now you know the pointers, effectively top was changing in case of a push and a pop, so it needs to be called by reference. In case of an insert queue, rear changes, so rear has to be called by reference. Delete queue, front was changing, so front must be passed called by reference. And along with all these, array without a problem, easy to pass. So array is not a problem at all, but others need to be passed as a call by reference. And because earlier we had not studied pointers, so I avoided to pass these as a call by reference and introduce a star there. To keep simplicity, I didn't tell that, but now is the right time to do so. So I'll stop here and practice this, and next lecture is going to be equally important to understand the remaining concept of pointers, and then linked list starts after this. Bye-bye. All the best to all of you.